folks, so today we are going to talk about exploratory data analysis as well as data visualization. Now, in theory, that's the plan. In reality, my Tukey is probably going to serenade us with some scratchiness. Yeah. He's being good. We will see how long this lasts. But anyway, welcome to Data and Visualization. We're first going to talk about exploratory data analysis. And I'm going to begin with a quote by John Tukey. Not that Tukey. We'll be exploring numbers. We need to handle them easily and look at them efficiently. I cannot speak today. We will be exploring numbers. We need to handle them easily and look at them effectively. Techniques for handling and looking, whether graphical, arithmetic, or intermediate, will be important. So what is EDA? So exploratory data analysis is an approach to analyzing data sets with the goal of summarizing their main characteristics. It's typically contrasted with confirmatory factor analysis, where you go in with a hypothesis in mind, and you care about testing it and falsifying it, while exploratory data analysis is much more descriptive. Its goal is to uncover, to explore, without an agenda. It's agendaless? But anyway, one of the key aspects of it is visual. But we can also calculate summary statistics, perform various data wranglings and manipulations and transformations at or before this stage of analysis. And that's what we'll focus on next. But this time, we're going to show you essentially why I call this class the pretty picture class with data visualization. So, another Tukey quote, a simple graph has brought more information to the data analyst's mind than any other device. A picture's worth 1,000 words. Data visualization is the creation and study of the visual representation of data. Many tools for visualizing data exist. R is one, and my favorite, because it's free and has lots of properties, as do many other approaches and systems within R. There are those outside of R, obviously. It's not like we invented the data visualization and R at the same time, like Tukey's books from the 70s. But anyway, I'm sidetracking myself. So, we're going to focus primarily on ggplot, and I've got a whole lecture on ggplot coming up. And that is primarily what we're going to use, but I encourage you to explore other options within R. ggplot is a subset of tidyverse. It's tidyverse's data visualization package, and the GG in ggplot 2 is short for Grammar of Graphics. So it's inspired primarily by the book Grammar of Graphics by Leland Wilkinson, who kind of provides this tool, this grammar, to enable us to concisely describe the components of a graph. Hadley Wickham's, that white space there should be higher. Oh, I'm not going to fix it now. Not going to. Okay, so Hadley Wickham's dissertation actually crawls deeply into this, and it gives a lot of the logic behind ggplot 2 in it. But here are the basic layers you've got, and you kind of smush them down. So let's start at the bottom. We got aesthetics, then geometrics, like the shapes. Then we got facets, which is slicing it down. Got statistics, coordinates, and theme. We will go through all of these, but those are like the key pieces that we will break down visuals into. But before we do that, I want to show you. I want to actually show you how the process works. So let's do that. with a first and reproducible example. Yes, a first and reproducible example. Ta-da! So we are going to load up a CSV that I have already put on Crayon, called highest points by state. Now, everything in this yellow box is literal R code that I ran and have running right now. So we're going to load our required packages and data. These include tidyverse, a couple little like bookkeeping things here, so that when I show you them, you'll see like about 10. You'll see 10 rows. I'll show you heights. All right. Cool. Yeah, so we're going to switch this from feet to meters just so that we have some nice numbers. But this is a basic rescaling. All right. So let's take a first look. All I did was asked it to print the data. I just told it heights. And it printed out the first 10 rows, which is exactly what the Tibble setting told us it was going to do. So here we have it's sorted alphabetically, which is fine, I guess. It doesn't really give me a sense of what's happening in the data. So here's what we're gonna take another look. We're gonna take a deeper look. A lot of exploratory data analysis and just meanderings in your data are just by looking. So what we're going to do is rearrange our data using the arrange function on our heights data frame. And we'll sort it by elevation. So here we've sorted from smallest Oh, my brain just melted. I'm sorry. I saw Florida and thought that was supposed to be Alabama. But anyway, okay. So, Florida. Here we've got the states with the least elevation. Florida is super flat, so is Delaware, Louisiana. And so, that gives us one look. It's okay. But, I mean, we're kind of looking at elevations. So, let's look at it from the other way. So what we can do here is arrange our data by heights and reverse or sort the elevation descending instead of the default, which is ascending, as you can see here. So it's like a function within a function. Now we can see that Alaska's on top. Got California, Colorado, Washington, Wyoming, and then Hawaii, which I guess is technically because it's a mountain, volcano, whatnot. But so we looked at the top 10, we looked at the bottom 10, we also looked at the first 10 alphabetically, which wasn't super helpful. Okay, so let's take a look again, thoughtfully. So our goal is to just have all this data, just in general, our goal is to write down the set of numbers, keeping as much detail as possible, but also pack them efficiently so we can see them all at once. Because one of the big problems we have here is we want all that detail, but we also are only getting snapshots of 10 at a time. And I could maybe set it to be 15 or 20, but then I'm running out of space on my slide. And I do not know how to shrink text yet. So that is a major bottleneck. So let's take a look using a stem and leaf plot. As we can see here, the decimal point is 3 digits to the right of the hat of the bar. So for states so here we're doing it by thousands. So for example, the lowest elevations, we had Delaware, Florida, were in the hundreds. And we also got some in the 200s, some in the 400s, 500s, 600s. But this gives us a way to look at our data and have some sense. Now we could expand this out. There are different settings you could do, but the stem and leaf plot, with the stems being the thousands digit, gives us some sense of what our data look like without losing the nuance within it. So we seem to have 2 humps, or maybe 3 humps. We got some outliers out here, and we got a lot of flat stuff, and then we got this chunk in the middle that's probably the Rocky Mountains. So, no, and here I've got narrative that I probably should have pushed ahead and gone. So here, notice that the parts of the numbers, the beginnings, are repeated. The first digit of each number is printed at the beginning of the line, and the remainder at the end. First digit is the stem, and the remainder are leaves. Exciting, I know. But this was a novelty back in the day as a way to capture a lot of data, get a sense of the shape of our distribution. One trick, and we'll see if I video edit it to do this, is tilt it on its side. Oh, here we go. Alright, so on the orange book, on my edition, we got our scatter plot, or our stem and leaf plot right down here, and it's on its side. So just kind of like the one we've got. Now, if you want to envision what this distribution would look like, ta-da! If you put it on its side, you can see the shape. And with some practice, you can kind of just like mentally do it yourself in your mind. Or you can do what I tend to do and literally just like move the paper. That's the one downside of shooting video and doing it kind of flat like this. I do not know yet how to do some animations. But I love the tilting. That's my favorite part of this type of plot. So here's what the stem and leaf plot kind of show us, that I kind of pointed out. Now we can look and match the specific variables, but we had Alaska at the top by itself. Now you can also do this as a frequency count if we only had this number, but here, remember, which is something I immediately forgot, is this is one person one state at 62,000 meters. 6,200 meters? 6,200 meters. I swear I am a quantitative psychologist. It is not some big fraud. I just can't read numbers or words out loud. Okay. So yeah, we got Alaska. That was at the bottom. We got the Western and Rocky Mountains and Hawaii. So those are all in that middle chunk, and then everybody else. And I've reproduced the plot here, which I had anticipated, and then silly me. So yeah, Alaska, the Rockies, and Hawaii, and everybody else. We got a lot more information from this little plot, this little pile, than we did when we sorted all the things. So let's take another look. Let's compare the stem and leaf plot, and this kind of shows you that sneaky thing. So comparing the stem and leaf plot with a density estimate. Here, we're using ggplot, and all this code is fully reproduced, so you can just copy and paste it from the slides. Wow. Anyway, and we'll go through and break down all these little pieces. But here we're applying ggplot to our dataset heights, and what we want to plot in terms of the aesthetic is elevation. And we want to break it down and apply all that and look at geom density. Oh wait, I have an animation. Alaska, where could it be? Ooh. Here we go. There it is. Right there. In case you missed that. So we got density. Density plus. We added an additional visualization piece. This little rug that kind of shows you where all the spots are. So we got Alaska right here. Then we got our Rockies in this chunk here, and everybody else. In theory, we could also superimpose a tilted stem and leaf plot somehow. But these slices, these pictures, and even that just pile of numbers gives us so much more to think about and work with than we had from that initial alphabetical list. So that is wrapping up our little introduction to exploratory data analysis and what it is, as well as a first meandering with data. Ow. So thanks for watching. I'll see you in a bit.